Access Minnesota, issues that matter to you. Access Minnesota brings you the newsmakers and the stories that shape our everyday lives, with analysis from University of Minnesota faculty experts.
While some may debate the causes of climate change, there's no doubt that even subtle shifts in long-term weather patterns can cause significant problems for agriculture. This month on Access Minnesota, we'll see how a warmer, wetter environment in the Midwest will affect the crops our farmers grow. We'll also look at a new exhibit at the University of Minnesota's Anderson Library that celebrates the achievements of a U of M plant pathologist who developed new methods to combat wheat disease. But first, the U.S. Department of Agriculture is funding a 5-year study at the U of M to help farmers adapt to changing climate conditions. Nicholas Jordan is a professor of agronomy and plant genetics at the University of Minnesota. Professor Jordan, welcome to Access Minnesota.
Thank you.
We're at the University of Minnesota's St. Paul campus. We have a number of different crops growing around us. Tell us more about the kind of research that's taking place here at the St. Paul campus of the University of Minnesota.
Yeah, so this is one of the, I think, 5 field stations that the university has all over the state, and all of them are for a whole variety of agricultural research, so crop plant breeding and trying out new sort of agricultural machinery and new kinds of ways of growing things, like growing trees and crops together, for example. So they're just general purpose places to try out new stuff in agriculture.
And the University of Minnesota is the recipient of a 5-year grant from the U.S. Department of Agriculture that will help farmers acclimate to changes in our climate. Tell us more about that grant and the kinds of research that will be taking place here at the St. Paul campus and also at the Rosemount Farm.
Well, the purpose of the grant was to try to figure out how to make what is now a really good and productive agriculture that grows corn and soybeans and our basic cereal crops, and to try to make it even stronger. And so one of the issues that agriculture is faced with is that if the climate is actually changing, the prediction is that it will change in that there will be a different kind of pattern and distribution of rainfall. So the prediction is that we'll get more rainfall at once, and so we'll get all this rain, and then we'll have longer periods of dry weather in between rainfall. And so that's something that agriculture needs to, and especially growing corn and soybeans, needs to adapt to. And so really figuring out some ways that we can essentially tweak the way that we grow those crops that will be practical for farmers to actually use is the centerpiece and the major goal of what we're up to.
We've seen a lot of weather extremes this year in Minnesota. Record snowfall, flooding, below average temperatures in the spring. We've seen above average heat and humidity, particularly in the month of July. What has growing crops been like this year? Have there been challenges that farmers have experienced that isn't true of a typical growing season?
Well, yeah. The difficulty in the spring was the delay in planting. And so quite a bit of the corn and soybean acreage of the state got a fairly delayed start in the growing season. And we've since had some pretty good weather, and there's been some good catching up in a lot of parts of the state. But it was quite difficult to get the crop in. So that was kind of the major thing this year.
What sorts of weather patterns do you think Minnesota farmers will be seeing in the years ahead, and how can crops be adapted to those changes in climate?
Again, the main issue is this change in the distribution of rainfall from, so that it's less even and uniform, and that it comes in larger amounts with longer dry periods in between rainfall. And so the challenge then with that is that we need to figure out some way of holding on to the water when it does come, and essentially storing it better in the soil when we've got it. And we also need a way of fertilizing our crops that's less affected by that changed pattern of rainfall.
How easy is it going to be to accomplish those goals?
There are a number of ways that things can be tweaked, as I mentioned. There are new systems that allow us to hold water in fields and then for a longer period of time in the winter and on into the spring, and then release it through the drainage system, the tile drainage system that you'll you'll find in many parts of the corn and soybean growing areas in Minnesota and the rest of the Midwest. So there are kind of engineering techniques like that that have to do with field drainage, and those are very important options. But the kinds of things that we're working on involve trying to change the way that rainfall is stored in the soil when it falls, and the way that nutrients are used by the crop and used also by all the microorganisms that are in the soil, which are very important to what happens to, say, nitrogen that's applied as a fertilizer to a crop.
What are some of your concerns specifically about Minnesota agriculture in the wake of these climate changes?
The difficulty is that we need an agriculture that does three things. Thing number one is an agriculture that produces a lot of the basic sort of food and fiber commodities. And that is not only the kinds of things that we've gotten, such as corn and soybeans, from our agriculture, but also other things, such as biomass for renewable energy, which folks are becoming more and more aware that agriculture could really help out in that. So that's one thing we need. The second thing that we need agriculture that preserves good hunting and fishing and recreational opportunities, and provides, diversified economic opportunities for rural communities. And we need those two things to be consistently produced, whatever the weather is. So we need, good production of food and fiber. We need good production of biomass for renewable energy. We need good hunting and fishing and swimming opportunities, for example, in rural places, against the backdrop of a changing climate. The climate is actually going to change.
What farming techniques are you discovering that can help farmers adapt to a new kind of climate?
Well, the goal of our project is to make it easier for folks who are growing large acreages of corn and soybeans to use these cover crops that can be grown in the fall, and they become dormant then in the winter, but survive the winter and then start growing in the spring. And they are a very good thing to do because they improve the quality of the soil, but they tend to interfere with planting the crop in the spring. And so we're working with a technique called ridge tillage that essentially just shapes the field into a permanent pattern of little ridges that are about a foot above these kind of little furrows in between the ridges. And the deal is that by growing the cover crops up on the ridges and then cutting the ridge down in the spring about halfway down, what you do is you dump all of the cover crop and all of that good cover crop plant biomass that's grown into these furrows. You plant your corn up on the ridge, or your soybeans up on the ridge. You've gotten the cover crop out of the way, so it can decompose without taking nutrients away from the corn and soybeans, and without making the soil cold. Those are the two key problems with cover crops. And what you do is essentially you dump all that good cover crop stuff into the furrow. You can create the hypothesis of our project is you create a little compost heap essentially in that furrow, and you have intense microbial activity in the soil for about 6 weeks that breaks down all that good stuff and stabilizes it. And then after about the first 6 weeks of the corn growing season, you go through and with a certain cultivator and dump all that good composty stuff back up on the row, and you build your ridge back up again, and that's the annual cycle. And we think that what that will do is will separate the things that you need to sort of improve over time the water holding capacity of the soil and its ability to hold on to nutrients. You can do that over time and grow your crop without interference. So the things that you need to grow a crop and the things that you need to build the quality of the soil are now separate from each other, and they're not getting in each other's way. And that's the kind of key innovation that we're really opening up the hood on and looking in detail into. Does it work? How does it work? And what kinds of places will it work well, and what kinds of places is it less suited for? So those are the goals of our project.
Nick Jordan, Professor of Agronomy and Plant Genetics at the University of Minnesota. Thanks so much for joining us on Access Minnesota.
My pleasure. Thank you.
When Access Minnesota returns, a look at historic research at the U of M that helped reduce disease in wheat crops around the world.
Access Minnesota will return after these messages.